What's up, Eric?
What's up, G?
What are you doing right there, dude?
Some calculus.
What's that? Explain that to me.
Oh, it's just, derivatives, integrations, and, word problems and stuff.
Show me then.
Alright, this is how you do it. Question A is read like this. Find the average acceleration of train A over the interval T and A. So, right here, as we're given here, we're already given velocity. And to find average acceleration of T and A, we have to do NVT, because that's how we find a derivative of a chart we're given like this. So we get the original equation, which is b minus f of b minus f of a all over b minus a. So it's f of 8 minus f of 2 all over 8 over 2. And you just substitute in your numbers you have on the chart, negative 120, 100, then all over 6, and then you get negative 220 over 6 meters per minute squared. Always remember to label even though it doesn't ask, and feel free to reduce. Question B is asking, do the data in the table support the conclusion that train A's velocity is negative 100 meters per minute at some time t with 5t 8? Give your reason for your answer. So obviously it's asking if train A's velocity crosses through negative 100 meters per minute. So as we can see in the table up here, 5 and 8 is 40 through negative 120. So as we can see, 100 is near here. So since the velocity is decreasing between the intervals of 5 and 8, and 40 is greater than negative 100, and negative 100 is greater than negative 120, according to the intermediate value theorem, there will be a time between the intervals 5 and 8 that train A's velocity is a negative 100 meters per minute. People usually don't think of the intermediate value theorem in the free response questions, but just a heads up, it might pop up then and there, and it's like a justification for the response.
So part C is asking for the position of train A, and it gives you at t equals 2 is 300 meters. So that will be your initial condition. And then it says use the trapezoidal sum with 3 subintervals indicated in the table that is up here. So you would use 2 to 5, 5 to 8, and then 8 to 12. So as you can see from our work right here, we have S of A, which is position of train A of 12, is S of A to 2, which is your initial condition given from up here, which is 300 meters, plus the integration from 2 to 12 of the velocity of train A of t, dt. And because it says to use the trapezoidal sum right here, we will use the trapezoidal sum. So as shown right here, which is, it's the same thing from up here, but then we use the trapezoidal sum, which is 3 times 100. The 3 is the difference from 5 to 2, and then we add 100 and 400. All that divided by 2, and then we get 3, which is the difference from 8 to 5, times 40 minus 120 divided by 2, and then we get 4, which is the difference from 12 to 8, times negative 120 plus negative 150, all that divided by 2, and from the trapezoidal sum we get negative 450. But then we have to include the initial condition, which is the 300 part, so it's 300 minus 450, which equals negative 150. So since originally the train was going east and the number is negative, that means the train's position is 150 meters west of the origin station.
Problem D is like this. A second train B, travels north from the origin station. At time t, the velocity of train B is given by VBT equals negative 5t squared plus 60t plus 25. At the time t equals 2, the train is 400 meters north of the station. Find the rate in meters per minute at which the distance train between A and train B is changing at time equals 2. To do this problem, it's related rates. You use Pythagorean theorem, take the derivative of that, and then you solve and substitute in for your values. X equals 300, Y equals 400, and Z equals 500. So right here you substitute 2 because it's asking at time t equals 2. You substitute in all your 2's, and then you find dz over dt, and you substitute all in your numbers, and you end up getting 80,000 over 500 equals 160 meters per minute. And here's a little demonstration of how you do this problem. So this is how you do the train problem.
Alright.
How did we get here?
Dude, I don't know, but that reminds me of a song I heard of.
This is dedicated to all the people who couldn't get a 10, thinking they're all just a bunch of ones, doing derivatives instead of integrations, getting beamed every day. Ha! It's all good, BC baby. It was all a dream, getting a 10 in BC, integrations and derivatives with the variable C, putting pictures in the wall, every Saturday going to boot camp, running down the hall. I programmed my calculator till I couldn't calculate, eating Nutella and bread, sipping on that Tampico, way back before the BC boot camp lingo, with PB to mix. Remember the Oilers dy dx, you never thought that math can get that complex.
Maybe I should cut Xavier to get a 10.
Cause you got the answer right. You know very well. This is BC.
That's how it goes. That's your rap.
Yeah, that's my rap, dude. What do you think?
I thought it was nice.
Yeah?
Yeah.
Does it help with that? Who's this guy?
Sorry. Looks like I'm getting a 10.